Electrical wiring and cabling. Hello folks, welcome to this lesson on electrical wiring and cabling. Understanding electrical wiring and cabling is crucial for ensuring efficiency and safety in various electrical systems. This lesson aims to provide a foundational understanding of electrical wiring, covering wire types, connectors, termination techniques, and best practices. Introduction to electrical wiring and cabling, for example, wire types, connectors, termination. Overview of electrical wiring and cabling. Electrical wiring involves the use of wires and cables to distribute electricity throughout a building or machinery. Proper installation and maintenance are essential to prevent electrical hazards such as fires and short circuits. Wire types. Different applications require different wire types, each suited for specific purposes. Single-core wire, used in small appliances and lighting because it is easy to handle and install. Multi-core cable consists of multiple conductors used for computers, communication, and electronics. Shielded cable contains a conductive layer that reduces electromagnetic interference, ideal for sensitive equipment. Twisted pair cable, common in networking applications due to its ability to reduce signal interference. Coaxial cable, used for TV and radio transmission, featuring a central conductor surrounded by an insulating layer and shielding. Connectors. Connectors are vital components allowing secure connections between wires and devices. Plug connectors, used to connect the end of a wire to a power source or another device. Examples include AC plugs and 12 volts DC plugs. Splice connectors enable connections between two or more wires. Common types include twist-on and push-in connectors. Terminal blocks provide a safe connection point for multiple wires commonly used in industrial applications. Termination techniques. Termination refers to how connections are made between wires and connectors. Soldering uses molten metal to join wires, creating a strong, reliable connection. Crimping involves compressing a metal sleeve around a wire to form a secure connection without solder. Screw termination. Wires are inserted into terminals and secured with screws. Used in many home and industrial wiring applications. Understanding wiring and cabling best practices. Adhering to best practices ensures safety and performance effectiveness. Safety precautions. Always turn off power before working on electrical systems to prevent shocks or accidents. Use appropriate personal protective equipment (PPE) such as gloves and safety goggles. Ensure that wires are properly insulated and grounded to avoid short circuits. Quality installation. Choose the correct wire size and type for the application to ensure proper load handling. Label wires clearly and accurately to help with future maintenance and troubleshooting. Secure and organize cables using ties and conduits to prevent damage and clutter. Regular maintenance. Conduct regular inspections to identify wear, corrosion, or damage to wiring. Replace aging components to maintain system reliability. Document any changes made during repairs to keep records up to date. Compliance with standards. Adhere to local and international standards and codes for electrical installations such as National Electrical Code NEC, U.S. standard providing guidelines for safe electrical design and installation. International Electrotechnical Commission, IEC, global standards organization focusing on electrical technology. Knowledge of electrical wiring and cabling is essential for anyone involved in installing or maintaining electrical systems. By understanding the different wire types, connectors, and best practices, individuals can ensure that electrical systems are safe, reliable, and efficient. Here's a summary of Introduction to Electrical Wiring and Cabling. Overview. Electrical wiring and cabling are crucial components of electrical systems, enabling the transmission of electrical signals and power. Wire types. 1. Solid core. Single, solid conductor. 2. Stranded core. Multiple, thin conductors twisted together. 3. Coaxial cable, central conductor surrounded by insulation, braiding, and an outer jacket. 4. Twisted pair cable, to insulated conductors twisted together. Wire insulation and jacket materials. 1. PVC polyvinyl chloride, common insulation material. 2. Teflon, high-temperature insulation material. 3. Rubber, flexible insulation material. 4. Nylon, outer jacket material providing mechanical protection. Connectors and terminals. 1. Screw terminals, secure wires using screws. 2. Lug terminals, connect wires to equipment using lugs. 3. Spade terminals, connect wires to equipment using spade-shaped terminals. 4. RJ45 connectors, commonly used for Ethernet connections. Termination methods. 1. Soldering, joining wires using a soldering iron. 2. Crimping, securing wires using a crimping tool. 3. Wire nut connectors, twisting wires together using a wire nut. 4. Push-in wire connectors, connecting wires using a push-in connector. Safety considerations. 1. Voltage rating, ensure wires and connectors can handle the system voltage. 2. Current rating, ensure wires and connectors can handle the system current. 3. Insulation integrity, ensure wire insulation is intact and not damaged. For proper termination, ensure connections are secure and meet safety standards. This summary provides a comprehensive introduction to electrical wiring and cabling, covering wire types, insulation materials, connectors, termination methods, and safety considerations. Here's a summary of overview of electrical wiring and cabling. Definition. Electrical wiring and cabling refer to the installation and use of electrical conductors, cables, and associated equipment to transmit electrical signals and power. Types of electrical wiring and cabling. 1. Low-voltage wiring used for telecommunication, computer networks, and control systems. 2. Medium-voltage wiring used for industrial power distribution and transmission. 3. High-voltage wiring used for high-voltage transmission and distribution. Components of electrical wiring and cabling. 1. Conductors, wires or cables that carry electrical current. 2. Insulation, materials that surround conductors to prevent electrical shock. 3. Jackets, outer coverings that protect cables from environmental damage. 4. Connectors, devices that join conductors or cables together. 5. Terminals, devices that connect conductors or cables to equipment. Electrical wiring and cabling systems. 1. Radial wiring system, a single cable or conductor that radiates from a central point. 2. Ring wiring system, a circular configuration of cables or conductors. 3. Bus wiring system, a centralized cable or conductor that distributes power to multiple devices. Applications of electrical wiring and cabling. 1. Residential, homes, apartments, and condominiums. 2. Commercial, office buildings, shopping centers, and restaurants. 3. Industrial, factories, manufacturing plants, and warehouses. 4. Telecommunication, telephone networks, internet connectivity, and data centers. Safety considerations. 1. Voltage, ensure wiring and cabling can handle system voltage. 2. Current, ensure wiring and cabling can handle system current. 3. Insulation, ensure insulation is intact and not damaged. For proper termination, ensure connections are secure and meet safety standards. This summary provides an overview of electrical wiring and cabling, including types, components, systems, applications, and safety considerations. Conclusion. In conclusion, proper electrical wiring and cabling play a critical role in modern infrastructure, impacting both safety and functionality. By adhering to best practices and understanding key concepts, you will be well equipped to manage electrical systems effectively. As you continue your learning journey, remember that hands-on experience, continuous education, and adherence to safety guidelines are crucial for mastering the art of electrical wiring and cabling. Thank you for joining today's lesson on electrical wiring and cabling. I hope to see you in the next lesson. Happy learning!